Okay, welcome back. Here you can see the solution to 1a. So what do you think? One thing that kind of jumps out at me here is the fact that notice there's a minus sign in there. What do you suppose caused that to be a minus sign? Yeah, it was the fact that we had a negative remainder. As you can see from my work here, what happened as we ran through and did all the division here, we ended up getting this value right here of negative 13. Whenever you run across a negative remainder, we can go ahead and write it as just a minus, and then we can write the remainder in there. Look at the next one. See that solution? Do we get that one? There's the work. Once again, there's a negative remainder in there. That's why you see a minus sign in there. Alright, now it's time to show you the fun stuff here, synthetic division. You notice that when we were doing long division, it can become quite tedious and quite monotonous, and it can really cause a little bit of frustration there. It'd be nice if we can try and streamline the process now, wouldn't it? So that's what synthetic division aims to do. It's just a shorthand way of writing and dividing a polynomial by only a linear binomial. That's kind of the catch here about this thing here when it comes to working with synthetic division. So when you take a look at this case here, and this looks quite familiar, we just worked with that one. Notice we have that 0x in there. Synthetic division only works when the polynomials are in standard form, as you can see there. So if it's not in standard form, rewrite it. And also, you also have to use zeros as for any missing terms. So we did that with long division. You're going to need to do it with synthetic division. You haven't seen it yet, but I'll show you synthetic division in a couple seconds. The other thing that has to be true for synthetic division to work is that your divisor must be in the form of x minus a. And I'll get into go into a little bit more detail in a couple seconds here. It does not have to say x minus a value for it to be an x minus a. It's just the opposite type of deal, and we'll get into that a little bit later. So just when something says x plus a value, we can still work with that with synthetic division. So here's the setup. With synthetic division, you're going to want to make this little setup here kind of like half a square and then a nice little line here. What this line actually represents is you're going to be doing a little bit of vertical addition going on here a couple of times. So right down underneath the lines, you're going to put your sums. So here's your first move. That x minus a divisor that you have right there. Notice I'm ignoring the minus sign. Because it's in the form of x minus a, that means that a is 2, right? And so if a is 2 in this form of x minus a, you need to put a value right in there. So we're going to put a 2 right there in that little half square there. The next thing we're going to do, synthetic division is faster because all we really need to worry about is the coefficients. So every one of those coefficients in your dividend, you're going to drop those right in there. Notice we're not writing the x's in there. We aren't going to need them. Now, how synthetic division works is every single time we get a new value, we're going to be adding it. Which I'd like you guys to notice as we go through there why this is different from long division. And in fact, synthetic division actually makes it a little bit easier. I'll give you a little bit of a preview. Do you remember when we were doing long division, we were doing subtraction after subtraction after subtraction after subtraction? Well, how could we make it addition after addition after addition? Might have something to do with the opposite number in there. Look at that. So minus 2 and plus 2. Now we can add. So the first thing you're going to want to do with synthetic division is that first number that you always have there, you're going to bring it down. Think of it like this. You're really taking 3 and adding 0 since there's nothing in there. So 3 plus 0, you've got 3. Very similar to this move over here. Whenever that term was, say, the coefficient was 3 in front, we knew that that part of the quotient had to have a 3 in it. So we end up getting 3x squared. Now what we're going to do is we're going to multiply the 3 and the 2 together with synthetic division. And when we get that product, which is 6, we're going to take that 6 and we're going to put it right there underneath the next number in line, which is the 4. Compare that to what we did here. 3x squared, distributive property, 3x cubed minus, there's that 6 right there, and there's a 6 right there through multiplication, right? Here's what we're going to do next. After we write the number here, now we're going to add up the new number that we had, the 6 here, with the old 4 that we had there previously. And then we end up adding them up and get 10. Notice the addition here versus the subtraction there. And just to take a little time out here, notice what we're getting down below, the 3 and the 10. Notice what we're getting here are the coefficients of the divisor. Of the quotient. So moving along here, we got that 10 sitting down there, right? Now, this pattern repeats itself. We're going to take the 2 and multiply it by the 10. Just like earlier, we took the 2 and we multiplied it by the 3. So 2 times 10 gives us 20. Then, what do you think it's time for? Now it's time to add. Now that we have two numbers there, we're going to add those up. And that gives us 20. You're kind of seeing at what stage we're kind of at the same time here with long division. That 20 that you're seeing right there actually doesn't show up in your long division until you do that move and you figure out that 20x divided by x gives you the 20. This 20 here and that 20 there. Now we have the 20 here. We still have an empty space right up here. And now we have this 2. Let's take that 2 and let's take that 20 and let's multiply them together. And there's your 40. Very similar to when we did the long division, we got the 40 right there, the negative 40. But see that minus 40? And now we're just simply adding the 40 here, which gives us that 50. So notice the remainders are the same there. Yeah, nice. So once you get that remainder value here, notice that we end up getting the remainder value here. So what you're going to want to do whenever you finish your long division, your synthetic division, is put another half square, very similar to that half square right there. What you're doing here is you're splitting off the remainder from your quotient. And here's how you make sense of those, the 3, 10, and the 20. The 3, 10, and the 20 is actually the coefficients on your new quotient. 3x squared plus 10x plus 20. That 50 that you had right there, that's going to be your remainder, and then we can drop it right on underneath there on top of an x minus 2. Remember, x minus 2 is just the original divisor that we had right over there. Now, I'd like you to notice something here about this and how I always get this question, and that is, how'd you know to make that x squared, Mr. Cook? Well, earlier, when we were looking at this work back here, notice that the original divisor had a degree of 3. We're taking something with a degree of 3 and we're dividing it by something with a degree of 1. And what happens when you take x to the third and divide it by x to the first? You get x squared. And if those are the biggest powers in your two polynomials, that quotient has no choice but to be a quadratic polynomial. So in other words, what I'm trying to tell you guys is that your quotient is always 1 degree less than your original dividend. Always 1 degree less. And here's the beauty part about synthetic division, is because we put it in standard form with the, excuse me for a second, if we had this written as the 3rd degree, the 2nd degree, the 1st degree, and the 0 degree, writing it in descending order, now we're down to 2, 1, 0, just like that. So x to the 2nd, x to the 1st, and x to the 0 power. And then that remainder takes care of itself. So let's try this again. Setting up the synthetic division. Notice, make sure that when you have a division sign like this, you have a clear understanding of which one's your dividend and which one's your your divisor. We are dividing by x plus a half. So that one's your divisor. So there, that 1/2, that positive 1/2, can go right in here. Now notice, like I was saying before, with synthetic division, they made a big stink about this, x minus a. Well, you can still use something like this. It just looks like this, doesn't it? X minus a negative 1/2. So now it's in the form x minus a. So now a is actually just negative 1/2, which is what we put right in there. So once we have our negative 1/2 put in place, now we drop in the coefficients. Take a quick second and just remind yourself where we got the 4, the negative 12, and the 9 from. Here, here, and here. Now, the first move with synthetic division is always bringing down that first number. Bring down the 4. We're adding 0 to it. What's the next move? Every single time you have a number down here underneath the horizontal line, you're always going to take that number, you're going to multiply it by that value. Your answer always goes in the next adjacent spot. And notice what I did there next also is I added that up. So negative 2 in there, and then we add those up, that gives us negative 14. Now what's it time for? number down here, take it, multiply. What's negative half of negative 14? It's going to be a positive 7. Then we add those up, 9 and 7. There's your 16. So there's your remainder. Now take a second. Remember the degree of the dividend was 2. So if we wrote this out as second power, first power, 0 power, the quotient is always 1 degree less. So now our new quotient here is 4x to the first minus 14 plus your remainder divided by your divisor. And the quotient will always be 1 degree less than the dividend. Let's try it again. Negative 3 right there. Wait a second, we're not going to use negative 3 because it's in the form of x minus a right now. Our a value is nothing more than 3. What coefficients are we going to put in here? Careful, take a good look. We have 1, we have negative 2. Notice fourth power, third power. Where's second power? I don't know. It's not there. So we need to put a 0 in there for that spot. And then there's our first power, so 3. And then there's our 1 right there. So we got to put a 0 in the proper spot. So we have it now. Fourth power, third power, second power, first power, 0 power. Bring down the 1. Multiply. Add those up. It really can start to go this fast. Multiply. Add those up. Multiply. Add those up. Multiply. Add those up. Boom. What's going to be the degree? What's the degree of the quotient? Because the degree here is 4, the degree is 1 degree less, so it's going to be cubic. Starting to get a feel for it? Alright. I'm going to stop talking. And it's time for you to go, go, go. And I'll see ya mañana.